Hola amigos! In today's video, in 12.3, we are going to learn about solubility, things that help things to dissolve faster. Remember, we have 3 words for dissolving, right? What are they? Dissolving is one of them, soluble or solubility is another, and then dissolution. So we're going to talk about factors. Factors are just different strategies, kind of. So factors are strategies that can help us to increase a substance's solubility. Basically, we're going to talk about things that make something dissolve better or faster. We also call that rates or rate of dissolution. What does dissolution mean? It means dissolving. So the rate of dissolving, okay? Rate means speed. So this is very similar to, we're talking about how to make something speed up, dissolving, how to make something dissolve faster, really. Okay, the first way that you can make something dissolve faster is to basically crush it. Now, why does that work? Why is that helpful? Well, we're going to talk about something called surface area. Surface area is the amount of your particle that's exposed to the solvent, okay? So your solute is your particle, the thing you're trying to dissolve, and the solvent is the liquid, okay? So usually our solvent is water. So if I have a cube, like a sugar cube or a salt cube, I only have 6 sides, okay? And then there's, a couple on the other, but four that you can see here and then 6 total. It's kind of like a dice. So there's 6 sides that are exposed to the water. The water can only dissolve those outside 6 sides. But inside the cube here, there's a lot of sugar, but it's covered up by that outside layer, right? So it's only dissolving the outer surface area. It's not dissolving anything inside the cube. So if we crush the cube, though, all of a sudden, I have 6 sides on this teeny tiny particle that are available to dissolve, right? And then I have 6 sides on this particle able to dissolve, and then 6 sides on this particle, and this particle, and this all of a sudden, I immensely increase the amount of my particle that's able to dissolve. So we say increasing surface area, also known as crushing, okay, is one way to make something dissolve faster, to increase the rate of dissolution. So dissolution is increased when we increase surface area. Okay, the second way we can increase it is by stirring, and this is my little drawing of a spoon being moved back and forth inside of a beaker. If we physically increase the movement of the particles in the solvent, then they will dissolve faster. So we say, and that's called agitating, which I know is kind of a funny word. Agitating a solution is like shaking a solution, mixing it, stirring it, applying force to physically make the solute mix with the solvent, okay? So let's review. We can crush the solute so there's more surface area exposed to the solvent. We can stir or agitate the solute inside the solvent so it forces it to mix. But we can also heat a solution. Okay, so heating a solution is another option, increasing its temperature. So this is a horrible picture of a fire right here. And as you can see, the particles, I drew arrows to show that they're moving faster. When particles move faster, it's basically like a different way of stirring. Okay, so you can physically stir, that's called agitating, or you can stir with temperature. By increasing or having something boil, then it mixes better. Okay. So in gases, if we're dissolving a gas, if the solute is a gas, if I'm trying to have a gas dissolved in a liquid, which is what they do with sodas, by the way, they dissolve carbon dioxide or they mix it into liquids. Temperature is a bad thing. If they increase the temperature, it will usually decrease the solubility of a gas. Okay, so the gases, if you're increasing their temperature, guess what these gases are going to do? Increased temperature means increased volume, so they leave, right? But if I do it for a solid particle, if I increase the temperature, it actually increases the solubility, which is what we were talking about above. Increasing the temperature helps the particles to move and mix inside of the liquid. Okay. The other thing we could do is we can increase pressure. Now, if I change the pressure of my coffee mug or my cup of lemonade, it doesn't really do much to it. That's because changes in pressure have very little to do with the solubility of liquids and solids. It really only changes the solubility of gases, okay? So if we increase pressure, if I push on a gas, it actually helps the gas to dissolve. So that's picture number 4. Here's a little bubble of gas, bubble of carbon dioxide inside of the Coke can. Okay, so there's a graph I want to show you that kind of depicts these three types of solutions, okay? So these two graphs right here, on this side of the graph, it's the amount of water. Okay, we have 100 grams of water in all of these solutions, okay? So they're all out of 100 grams of water. This number right here tells you the grams of solute that is dissolved in that 100 grams of water, okay? And then down here at the bottom, this represents the temperature of the solution, okay? What can you tell as temperature gets higher and higher? What is happening to the amount of solute that's being dissolved? See how all of these lines start going upward? Remember, this is the grams of your particle that's being dissolved. So as we increase temperature, we can see that it can hold more solute as it increases in temperature. So let's fill that in. These graphs show the function of temperature on solubility, and the general rule is increasing temperature will increase solubility. Okay, so let's look at a couple substances here. The first question asks us which substance is more soluble at 50 degrees Celsius. Well, first let's find 50 degrees Celsius, okay? Here's 50 degrees Celsius. So I'm going to look at this line. It says which substance is more soluble, meaning which one can dissolve more solute. Is it sodium nitrate or sodium chloride? So sodium nitrate is right here. Here's sodium nitrate, and here's sodium nitrate's line. So where does sodium nitrate intersect at 50 degrees? It intersects right here. See that spot? So I'm going to draw a line to that spot. And that's, I'm not very good at drawing these lines. I'm going to guess it's 115. So we say 115 grams of sodium nitrate is dissolved at 50 degrees Celsius. Now let's find our other substance. The other substance was sodium chloride, which is right here. That's sodium chloride. Sodium chloride intersects 50 degrees Celsius at this point right here, which to me, if I connect it over to the side, it looks like it's close to 40, but not right at 40, so let's say 38 grams. So which one is more soluble? Which one dissolves more? Well, it's obviously sodium nitrate, right? Because it makes more, it dissolves more than sodium chloride did. This next question is, it's asking really the same exact thing. It says for us to look at 90 degrees Celsius. So here's 90 degrees Celsius, right about there. And it's asking for sodium chloride, which sodium chloride is this line right here. There's sodium chloride. So where does it intersect that temperature, 90 degrees? It intersects right here, which is right at this line, which I think is probably right at 70 degrees. Or not 70 degrees, 70 grams. So it makes about 70 grams this much, 70 grams of sodium, 70 grams of ammonium chloride will be dissolved at that temperature at 90 degrees. Now you might be asking yourself, well, what about this? It says how much of it can be dissolved in 100 grams of water. Well, that's just actually telling us which graph to look at. This graph automatically tells us that every single line is in 100 grams of water. Okay, so it's just telling us to look at that particular graph. All right, let's look at question 3. When I first look at question 3, I want to notice a couple things. I want to notice the temperature that it wants me to look at, which is 90 degrees Celsius. I also want to note the substance it wants me to look at, which is, oh, I'm sorry, I'm on the wrong one. The temperature that it wants me to look at is 65 degrees Celsius. The substance that it wants me to look at is sodium nitrate. And then I also want to look at if it gives me any other additional information. So it also tells me that there's 140 grams dissolved in it. And it's asking me if the solution is saturated, unsaturated, or supersaturated. So let's start by just finding the things that I just highlighted. So first, I want to find where 65 degrees Celsius is on this chart. So 65 is going to be right in between 60 and 70. So let me draw this line. Now I'm going to find my substance. My substance is sodium nitrate. Nitrate is NO3. It's polyatomic. So it's right here. So I'm going to highlight that line. And then I want to note where it intersects. Okay, so it's intersecting right here. It's intersecting right at 130 degrees, not 130 degrees, 130 grams. So what we know about this chart is this chart tells us that at 60 degrees, 65 degrees, sodium nitrate will have 130 grams dissolved. Let me say that again. At 65 degrees, sodium nitrate will have dissolved 130 grams, or will be able to dissolve 130 grams. This question tells us that there's more than 130 grams dissolved. It says it contains 140 grams. And let's say that it's 140 grams fully dissolved. Let's just assume that all of that is fully dissolved, okay? Well, a couple things we know from a graph is we know that this is what we call the saturation point, okay? So the point that I circled right there, that's known as a saturation point. That is the point at which the substance is saturated. This tells me how much sodium nitrate can be dissolved at this temperature, okay? So the saturation point at 65 degrees Celsius is 130 grams. That's how many grams of sodium nitrate can be dissolved at 65 degrees Celsius. So if we have 130 grams exactly dissolved, we would say it's saturated because it's at the saturation point. If we said we only dissolved maybe 120 grams, so if we have anything lower than the saturation point, we say it's unsaturated. So you might want to write that down. If you dissolve less than the saturation point, then we say that it's unsaturated. So if you dissolve less than the saturation point, it's unsaturated. However, if we're somehow able to dissolve more than 130 grams, if you can dissolve more than the saturation point, then we call that supersaturated. Remember, if you're able to dissolve more than the maximum amount of solute, it's supersaturated. So that probably means they did something to increase the saturation, like they either they did something to make more solute dissolve. If it's right at the saturation point, we say it's just regular saturated. So since our problem said they dissolved 140 grams and we know they really only should have dissolved 130, that means we know it's supersaturated. Okay, let's look at question 4. Okay, so I read question 4, and again, I always note a couple things. I note the temperature that it's talking about. It's talking about 37 degrees. So it's right here, almost at 40 degrees. So I marked my line for 37 degrees Celsius, okay? It's talking about 100 grams of water. We know, remember from this graph, that everything on this graph is dissolved in 100 grams of water. So that's really extra information. We don't really need that right now. It's saying how many grams of solute will be at the bottom if 120 grams was put into the container. And really, it shouldn't say is dissolved. I really should say is added. Okay. So if we add 120 grams of sodium nitrate, how much will fall to the bottom? Okay. So let's find our substance. Sodium nitrate. Where is sodium nitrate? Sodium is right here. And then nitrate is NO3. So here's sodium nitrate. It's the same substance from before. And let's find its saturation point. So how much sodium nitrate should be dissolved at 37 degrees Celsius? Well, that to me looks like it's right at 100. I think it's right at 100. So if it's right at 100, then I say that's the saturation point. The saturation point is 100 grams. That's how much can be saturated in the beaker. What happens if I add more than that? If I add more than that and I don't do anything to change the temperature or anything, if I just leave it normal and I add more solute, it's going to fall to the bottom. It's not going to dissolve. So if I added 120 grams and I know that only 100 will dissolve, I know there'll be 20 grams left over on the bottom. Here's my beaker. 100 grams will be dissolved, but 20 grams will be undissolved here at the bottom. Okay, so I write down 20 grams as my answer. And that is it for our video on solubility curves. You may now attempt the challenge over 12.3, and y'all have a fantastic day.